Welcome to another AI pattern recognition deep dive.
The world we live in today, it's just a flood of information, isn't it? We're
Yeah.
talking about petabytes of data being generated every single second.
Every second. It's almost impossible to comprehend.
And it's all governed by these billions of variables, these nonlinear relationships that, well, they just seem to be moving faster than our ability to keep up.
They absolutely are. Our capacity for analysis, and maybe more importantly, our response time, is being completely outpaced.
Exactly. I mean, think about trying to manage global climate modeling
And at the same time, global supply chain volatility.
and personalized preventative health care for millions of people all at once. They all interact in ways we can barely even begin to map out.
We're drowning. I think that's the only word for it. We are drowning in systemic complexity.
And that complexity,
Oh.
it's not just, an inconvenience. It feels like an existential barrier. It stops us from solving the really big global crises.
It is, because human reaction time is just too slow. Our perception, our ability to grasp the whole picture, is too limited to see the true scale of all these interconnected risks.
So we need a system that can see it for us.
We need a system that can process, say, 10 to the 17 data points a second. That's the kind of scale you need if you actually want to get ahead of these problems instead of just reacting to them.
Which is the perfect entry point. Today, we are taking a deep dive into a blueprint designed to tackle that exact challenge head-on. It's called AGIHR AI.
AGI, Hardware Requirements AI.
Yes, and I'll admit, it's a clunky, very technical name.
It is a bit of a mouthful.
But the vision behind it is anything but narrow. This isn't just a technical spec for building another supercomputer. It's a holistic blueprint.
A completely new way of looking at the problem.
It proposes optimizing everything, and I mean everything from global infrastructure and how we allocate resources, right down to the pathways for human development. And it does it all by systematically learning to see the hidden patterns that we currently miss.
And our mission for this deep dive is really to give you, the listener, the complete picture. We're going to get into the nuts and bolts.
The hardware, the insane computational needs.
And then we're going to connect that to the staggering breadth of its proposed applications. How could one single generalized intelligence system theoretically guide everything from your unique personal health metrics?
All the way up to the biggest, most existential challenges facing global climate policy.
That's the question we're tackling.
So before we get into the circuits and the software, let's start with a really precise definition. What is this AGIHR AI system actually trying to do? What's its mandate?
Okay, at its absolute core, AGIHR AI is defined as a comprehensive pattern recognition system, and it operates across 5 interconnected objectives.
Okay, what's the first one?
First, it has to define the hardware and the computational power needed for true artificial general intelligence. That's the HR part, the hardware requirement.
With foundation.
Exactly.
Yeah.
Second, and this is the most critical part, it has to recognize and synthesize patterns across all 7 essential human and planetary domains:
So biological, social, economic.
environmental, political, educational, and even psychological. All of them interconnected.
What's number 3?
It has to provide real-time analysis. The insights have to come quickly enough to actually matter in a crisis.
So it can't take weeks to run a model.
No, seconds. And fourth, it has to adapt. It has to continuously learn from every single interaction and every outcome. It's not static.
And the final objective, the purpose behind it all.
Its overriding purpose is to guide human decision-making by giving us pattern-based foresight. Essentially, it's a mirror. A mirror designed to show us the whole messy, complicated picture of ourselves and our environment, and to point out where the cracks are forming long before they break.
Okay, so let's try to unpack this a little. If the goal is truly universal pattern recognition,
Which is an incredible ambition.
it is. I mean, if we want an AI that can manage a health crisis and optimize a power grid simultaneously, we're talking about computational needs that they dwarf today's narrow AI systems.
They're on another planet entirely.
So what is the fundamental technical foundation? What do you need to run this kind of comprehensive continuous analysis?
The requirements are, well, they're immense. The goal is to have capabilities that are comparable to simulating, or at least functionally matching, the complexity of the human brain.
But applied at a global scale.
Exactly, applied at a global, interconnected scale. So we have to start with the physical infrastructure, the very engine room of this whole framework.
Lay it out for us. What kind of sheer computational power are we talking about to process, the entire world in real time?
So based on research into brain modeling and how current large language models are scaling, To get to AGI capabilities, you need computational power ranging from 10 to the 14 up to 10 to the 17 floating point operations per second.
FLOPs.
Right, FLOPs. And that upper figure, 10 to the 17, that's widely accepted as the processing power of the entire human brain.
Wow. So the system has to be capable of, well, brain scale computation just to keep up.
Just to keep pace with the sheer volume and the complexity of the data inputs from all 7 of those domains we just mentioned.
And I imagine that kind of processing power demands an equally enormous amount of memory to hold all the models and the working data sets.
You're absolutely right. Memory is a huge bottleneck here. The minimal requirement, just for immediate operational status, so a system that can handle one domain efficiently, is already what we'd consider high-end today. 256 gigabytes of high-speed DDR5 RAM.
And just to put that in perspective for you, your top-of-the-line gaming PC might have 32 or 64 gigabytes. So this is a big step up, even at the minimum.
A very big step up. But if the goal is truly ambitious, if you're talking about brain-scale emulation to handle the full complexity of all the human domains,
Yes.
the memory requirements scale dramatically, up to 68 terabytes.
68 terabytes of RAM.
Of hot working memory. And that colossal jump from gigabytes to tens of terabytes, that really illustrates the difference between a narrow, specialized AI and a generalized, comprehensive system that's looking at everything at once.
You're going from a single specialized brain to a kind of global collective intelligence.
That's a great way to put it.
Okay, I have to stop you there because we've hit a major tension point in the source material right out of the gate.
I think I know where you're going with this.
We just talked about needing 10 to the 17 operations per second and 68 terabytes of hot RAM. Today, that would require a data center the size of a city block, consuming vast megawatts of power.
Correct.
So how does the source reconcile that with the goal of hitting less than 100 watts? Isn't that the biggest, most science fiction hurdle in the entire blueprint?
It is the defining paradox of AGIHR AI, and it means we need a complete technological revolution in how we design computer components.
It's not just about making things faster.
Not at all. Achieving 10 to the 17 FLOPs is one challenge. Doing it while targeting less than 100 watts per system, that's a whole different ballgame. You're aiming for human brain efficiency.
Which runs on what, about 20 watts? Like a dim light bulb?
About 20 watts, yes. The only way to bridge that gap is through specialized, hyper-energy efficient processing units, not traditional CPUs or even the standard GPUs we use today.
So what are these components? What's actually crunching these numbers? And how do they balance that need for both brute force and extreme efficiency?
The architecture has to be heterogeneous. It's a mix. It relies on a combination of cutting-edge and very specialized units, each serving a distinct purpose.
Let's start with the general-purpose components. What's in the mix there?
So first, you need the high-performance general-purpose GPUs, things like the NVIDIA A100 and the newer H100. These are absolutely essential for the massive, high-throughput training and inference workloads we're familiar with. They give you that raw, parallel processing power.
And the source also mentions consumer-grade cards like the RTX 4090. That's interesting.
It is. It suggests a strategy for distributed workloads. It means you can leverage existing infrastructure in a decentralized way, which is key for cost efficiency and wide-scale deployment.
Okay, and what about Google's TPUs? Where do they fit in?
Google's tensor processing units are in there because they're optimized specifically for the kind of math that deep learning relies on matrix multiplication. They offer superior performance per watt for those core machine learning algorithms.
So for the day-to-day work of the neural networks, they're just more efficient.
Far more efficient than a general-purpose processor.
But even with all that, you're not getting down to 100 watts. The true bridge across that efficiency gap, as you said, it has to be the neuromorphic chips.
Absolutely. Neuromorphic chips like the Intel Loihi 2 or IBM's True North are fundamental to this entire architecture. They are the secret sauce.
Explain what makes them so different.
Well, they're designed to mimic the biological structure and the spiking behavior of the brain. They process information using what are called spiking neural networks rather than traditional clock-based cycles.
So it's a completely different way of computing.
A complete paradigm shift. And it's the only known pathway to achieve that brain-level energy efficiency we need. Without the success of these neuromorphic chips, that 100-watt goal, and maybe the whole framework, is basically unattainable.
So we have petabyte-scale storage for the data, and this highly optimized mixed architecture running it. Now let's move from the physical to the conceptual. How does AGIHR AI actually process all this information. The source describes a very strict linear flow.
It does. It's a crucial 8-step pipeline, and it's designed to ensure the system stays constantly adaptive and recursive. It's a learning loop.
Walk us through that operational rhythm step by step.
Okay, step 1, data collection. This is the start. Gathering raw data from every imaginable source, environmental sensors, health trackers, economic transactions, social media, you name it.
Then what?
Step 2 is pre-processing. This is the cleanup phase. You have to clean, normalize, and standardize all these incredibly diverse data streams so they can actually talk to each other.
Making apples and oranges comparable.
Exactly. Step 3 is feature extraction. This is where the system starts to identify the meaningful variables, the indicators that actually matter from all the noise. This is where the AI starts to prove its worth, spotting subtle markers a human would just completely overlook.
And then the core of the system.
Step 4, pattern detection, the main event. This is the moment the specialized machine learning algorithms find the relationships, the anomalies, the recurring sequences in the data.
And once this finds a pattern.
Step 5 is classification. It categorizes the pattern into a known type. For example, recession warning, early-stage cancer biomarker, or social conflict trigger.
And from there, it looks to the future.
Right. Step 6 is prediction, forecasting future states based on those classified patterns. What happens next if this pattern continues unchecked?
Which leads to step 7.
Action recommendation, generating specific data-driven guidance for human users or even autonomous systems to implement.
And the final step closes the loop.
Step 8, continuous learning. This is a feedback loop. The outcomes of those actions are fed back into the system to refine everything, feature extraction, pattern detection, and keep the system perpetually adaptive.
So that continuous learning loop is what stops it from being a static model. It keeps it relevant in a world that's changing by the second.
Precisely. It ensures that if a pattern suddenly shifts, let's say global supply chain norms change overnight because of a pandemic, the system doesn't get stuck relying on obsolete historical data. It learns and moves on.
Okay, let's move on to the actual engines of discovery, the machine learning techniques that make this whole thing run. We're looking at a mix of familiar and highly specialized methods here, right?
We need every tool in the modern AI toolbox. The data domains are just so varied and complex that a single algorithm couldn't possibly handle everything from genomic sequencing to political discourse analysis.
Let's start with supervised learning. This is for when you have labeled data like existing disease diagnoses or, documented policy outcomes.
Supervised learning is essential for reinforcing known patterns and automating routine analysis. You've got neural networks, of course, mapping inputs to labeled outputs, like matching a satellite image pattern to known deforestation.
But the source specifically calls out support vector machines, or SVMs. Let's pause on that because that's classic jargon. Why are SVMs so important here?
Okay, so think of an SVM as trying to find the single best, cleanest dividing line between two wildly different sets of data in a really messy, multidimensional space.
Okay.
So if you're classifying complex behavioral data, say trying to separate high-risk financial transactions from normal ones, or different types of social interactions, SVMs are excellent because they handle those messy data sets really well. They excel at finding sharp, clear classification boundaries.
I see. And decision trees are also in there.
Yes, mostly for mapping clear, explainable cause and effect relationships in structured data. That's especially useful in something like policy analysis, where transparency is absolutely critical.
Now, unsupervised learning. This is where the AI really starts to find new knowledge patterns we don't even know exist. This has to be crucial for a system focused on universal pattern discovery.
It's the engine of insight, absolutely.
Yeah.
We rely on clustering algorithms to group population data and find hidden demographic or behavioral patterns we weren't even looking for.
Like what?
This could reveal, for example, underserved communities that share similar health risks or educational needs, even if they're not geographically close.
That's powerful.
And then you have anomaly detection, which is maybe the most vital component of all. It identifies deviations from normal patterns. This could signal anything from the first subtle sign of a rare disease in a patient's blood work to a zero-day exploit on a network. The whole goal of AGIHR AI is to flag the unique, the unexpected, and the potentially catastrophic.
And we also see dimensionality reduction listed, which makes a lot of sense considering we're trying to manage billions of variables.
Dimensionality reduction is all about simplification. It lets the system distill those billions of variables down to the few hundred or maybe thousand essential factors that truly explain what's going on without losing the critical information. It makes the complexity manageable.
Then we get into deep learning, which is what gives the system its ability to perceive and predict complex sequences and patterns.
Deep learning is the backbone of its advanced perception and its ability to look forward in time. You have convolutional neural networks, CNNs, which are essential for processing visual and spatial data.
So that's medical imaging, satellite photos.
Medical imaging, analyzing land use from space, monitoring factory floors, all of that. Then you have recurrent neural networks, RNNs, and especially LSTM's long short-term memory networks. They're crucial for time series and future state prediction.
Okay, let's quickly clarify LSTMs. They're the key to prediction, right?
They're critical because they have these memory cells that let them remember information for long periods of time. So if you're trying to predict the path of a recession, you need to remember economic activity from 2 years ago, not just last month. LSTMs can track those long-range dependencies.
And what about the big guns, the transformer models?
They're in there because they understand complex contextual relationships. This is vital for analyzing human communication, political discourse, that sort of thing. They can grasp nuance in language, identify subtle shifts in polarization across a huge network of communication.
Finally, reinforcement learning, RL. This is where the AI learns by doing, by trial and error, to maximize a reward over time. This feels like the part that teaches the system long-term strategy.
That's it, exactly. RL is the ultimate decision maker and optimizer. You have things like Q-learning algorithms to optimize specific, immediate decisions like the best routing for emergency vehicles in real time.
And then there's policy gradients. That sounds highly technical. Why is that so important for governance?
Because governance isn't just one decision, it's a long sequence of decisions aimed at maximizing benefits over decades. Policy gradient methods teach the system how to maximize that long-term strategic success, even if it means making some short-term choices that seem suboptimal.
So it teaches the AI to play the long game.
The very long game. It allows the AI to learn the best sequence of actions to maximize human well-being over, say, 30 years. It's crucial for running those complex virtual policy simulators we'll talk about.
That gives us a really clear picture of this vast and complex foundation. It's a system built for maximum adaptability, scale, and, as you said, long-term strategic thinking.
And what's so fascinating here is that we shift from that technical engine room to the messy reality of the world. The blueprint isn't just about speed and memory.
Right. It's about synthesizing knowledge across these 7 distinct human and planetary domains.
It has to understand all of them to achieve that comprehensive foresight.
This is where the 68 terabytes of memory really start to earn their keep. Let's walk through these 7 layers, starting with the one at the core of all our collective actions. Human behavior patterns.
This domain focuses on the underlying, the social software that governs how we all interact. AGIHR AI tracks social dynamics, specifically that balance between cooperation and competition.
So tribe versus tribe, company versus company.
Exactly. It analyzes individual and collective decision-making to spot our inherent cognitive biases, to assess risk accurately, and to monitor emotional patterns, recognizing stress indicators, mental health signals, and big shifts in societal mood.
And communication patterns, too.
Meticulously, specific language use, conflict resolution styles, how ideas spread.
This is so far beyond just counting likes on social media. It's trying to measure the subtle quality of human interaction. Give us an example of how this translates into a proactive, personalized application.
Okay, the most direct one is mental health monitoring. Your wearable devices, your watch, your ring, they detect subtle, non-conscious changes in your sleep, your activity levels, your heart rate variability.
Things I wouldn't even notice myself.
Exactly. The AI identifies these subtle, long-term patterns that indicate chronic stress or depression or anxiety, and it does it before the clinical symptoms or a crisis fully manifests.
So it can recommend an intervention early.
A truly personalized one. Maybe it suggests shifting your work hours or getting more morning light exposure, or even recommends specific social interactions based on what it knows about your personal response patterns.
The sources also talk about social cohesion. How on earth does an AI measure something as abstract as community fragmentation?
It measures the patterns of interaction and language. It looks across digital networks and sees when communication patterns start to form closed echo chambers, when shared language decreases, and when emotionally charged, divisive rhetoric starts to rise.
It sees us pulling apart.
It sees the polarization trends in real time. And importantly, it recommends bridge-building activities based on successful historical patterns. Maybe it suggests a neutral shared project or a specific dialogue format that has worked to mitigate conflict in similar communities in the past. It's all about making our destructive, unconscious patterns visible.
Okay, moving from the social to the physical self,
Yeah.
human biology and health patterns. This is where that predictive capability could truly save lives.
No question. The mechanisms here track the incredibly complex patterns of disease progression through subtle biomarker changes, temporal shifts in physiological data. It monitors genetic expression for personalized medicine, it correlates lifestyle with long-term health, and it tracks epidemic patterns across populations.
The application examples here are, frankly, revolutionary, especially the claims around early detection.
They are. For personalized health management, the AI continuously analyzes your personal data, your heart rate, glucose, sleep to identify your unique personal normal baseline.
Not some generic average for my age group.
What?
Personal normal.
Your personal normal. Any deviation from that highly specific baseline triggers a preventative alert. It shifts the entire focus from treating illness to maintaining a dynamic state of optimal wellness.
And let's focus on that disease recognition claim. The source cites the potential for cancer detection up to 40% earlier than traditional methods. What is the AI seeing that a highly trained radiologist might miss?
It's about nonlinear perception. Traditional diagnostics rely on recognizing macroscopic patterns, a tumor of a certain size, a specific cell shape. The AI, running these advanced CNNs, recognizes subtle texture patterns, micron-level shifts in imaging data, and complex correlations between dozens of biomarkers that are simply too faint or too numerous for human perception to integrate.
So it's seeing the storm gather before the first raindrop falls.
That's a perfect analogy. It can spot precancerous cellular organization patterns weeks or months before they become a clinically visible mass. Similarly, for cardiac events, it can predict them by analyzing subtle, long-term rhythm variations that signal future instability.
That 40% earlier detection. That alone could fundamentally redefine oncology and public health. Okay, next up, human education patterns.
This domain is all about optimizing how we transmit and acquire knowledge, essentially creating the highest possible return on investment for human capital.
So how does it do that? What are the mechanisms?
It tracks specific learning styles, visual, auditory, kinesthetic. It identifies precise knowledge gaps in real time. It monitors engagement patterns like attention span and motivation. And it tracks the most efficient path for skill acquisition for each individual.
This sounds like the blueprint for true adaptive learning systems.
Precisely. The AI monitors a student's interactions, analyzes patterns of hesitation or repeated errors, and adjusts the difficulty, the pacing, even the medium of the lesson in real time. If you show strong visual retention, the AI automatically shifts the lesson toward diagrams and videos.
And it works at the system level, too, not just for the individual.
Right. It tackles educational resource allocation. By predicting future skill demands from economic patterns and identifying where current investment is failing, it can help optimize teacher placement, curriculum development, and funding to underserved populations.
Let's move to human politics patterns. This feels like the domain where human irrationality and bias can really throw a wrench in the works.
And that's why it's so critical for societal stability. The mechanisms here are analyzing long-term voting behaviors, modeling the impact of policy, really digging into the cause and effect, tracking polarization trends, and assessing governance effectiveness across different cultures.
The big application here is policy simulation. This sounds like trying to apply the laws of physics to politics.
In a way, that's the analogy. AI models predict policy outcomes before they're implemented by running them through these complex simulations. It matches a proposed policy against thousands of historical and cross-cultural examples.
And crucially, it spots the unintended consequences.
The ones that humans would take years, even decades, to spot. It moves policy planning from guesswork and ideology to evidence-based results.
And it also contributes to what the source calls democratic health monitoring,
which is more vital than ever. AGIHR AI tracks participation patterns to identify potential voter suppression. It monitors how misinformation spreads through a social system, and critically, it predicts social unrest.
How does it predict something so complex?
By tracking the accumulation of grievance patterns. It identifies when localized discontent in different groups starts to correlate and amplify, signaling a potential collective breakdown.
That systematic approach leads us right into human economics patterns, where misallocation and instability can have these devastating global consequences.
This domain tracks global market trends, analyzes consumer behavior, and meticulously studies resource allocation, constantly comparing efficiency versus waste. And it continuously monitors economic inequality and its correlation with social stability.
So what are the big wins here? The source makes some very bold claims about efficiency gains.
Economic forecasting is a major one. The AI can analyze real-time data on transactions, employment, inventory, and identify recession warning patterns months in advance by integrating all those disparate data sources.
But the most striking specific gain you mentioned earlier is resource optimization, slashing supply chain waste by 30% to 50%. How does pattern recognition achieve that?
Well, supply chains are just full of waste from forecasting errors, inefficient routes, and over-ordering because nobody has real-time visibility. AGIHR AI monitors every node, every truck, every inventory level, identifies bottlenecks in real time, and predicts demand with vastly higher accuracy.
So it just smooths out the entire system.
It eliminates wait times, optimizes routes, and prevents the need for massive buffer stock. That translates directly into trillions of dollars saved and a huge reduction in carbon footprint.
Okay, next we move to environment and nature patterns, the domain of planetary scale and, frankly, existential threat.
The mechanisms here are pretty clear. Tracking climate change patterns, especially extreme events, monitoring biodiversity and ecosystem health with satellite and sensor data, tracking resource depletion, and analyzing pollution trends.
And the application of this is vital for climate action.
It allows for proactive strategies. The AI can process all this high-resolution data to spot the subtle shifts that signal major weather changes. Critically, it can predict extreme weather, hurricanes, floods, heat waves 3 to 7 days earlier than traditional models.
That's a huge amount of time for preparation and evacuation.
It's life-saving time. And for conservation, it uses that anomaly detection we talked about to spot patterns of illegal fishing or logging, and it can predict the spread of invasive species.
Finally, the seventh domain, human nature, patterns, psychology, and consciousness. This is the attempt to map the inner world.
Right. This is the domain that tries to map what makes us uniquely human and often uniquely irrational. It monitors cognitive bias patterns in our decisions, our states of consciousness like awareness and attention. It tracks creativity patterns, and it analyzes how we make meaning in our lives.
So the applications here are about optimizing the self.
And understanding our blind spots. Cognitive enhancement uses AI to identify your optimal working or learning times based on your internal cognitive rhythm. It can also flag known biases like confirmation bias in your decision-making process in real time.
And well-being optimization.
That tracks patterns associated with long-term life satisfaction. It identifies pathways that successful people have taken to find purpose and recognizes resilience patterns to develop highly targeted stress management training.
It's clear that AGIHR AI sees the world not as a collection of separate problems, but as one massive, deeply interconnected system of patterns, from the cell all the way up to the global ecosystem.
Yeah.
We've laid out the complex mechanics and the truly astonishing breadth of these 7 domains. So now let's pivot to the big question. Why? Why do we need a system that can process 68 terabytes of memory and monitor human nature patterns?
And here's where it gets really interesting. The simplest answer is that complexity has definitively outpaced human governance and our own biological perception.
Detail that for us.
Yeah.
What specifically is blocking our human capacity right now?
Well, we're defeated by 3 main factors. First, nonlinear relationships. Modern systems are so interconnected that a small cause can have an unpredictable, massive effect that just defies linear thinking.
The butterfly effect on a global scale.
On a global scale. Second, temporal constraints. Things change so rapidly in finance, in climate, in public opinion, that they constantly outpace our response times. By the time we recognize a crisis, it's often too late to stop it.
And third,
hidden patterns. There are crucial, subtle signals that are just invisible to our perception because they require integrating billions of data points over decades, or they require superhuman resolution, like those subtle texture changes in an early cancer scan.
So this forces a massive systemic shift from being reactive, always managing crises after they start, to adopting a genuinely prevented posture.
That is the core driver. AGIHR AI provides the pattern recognition necessary for prevention across every single sector. We shift to early warning systems that prevent crises rather than just reacting to them.
Like predictive maintenance for infrastructure.
Exactly, avoiding catastrophic failures before they happen. Proactive healthcare allows treatment before symptoms even emerge. And maybe most strategically, anticipatory governance allows for policy planning before societal problems can even materialize.
Now, crucially, the sources hammer this point home. This is about human augmentation, not replacement. How does the framework ensure that fundamental distinction stays clear?
The explicit design goal is to enhance our capabilities by offloading the pattern-finding task. The AI expands our perception beyond our biological limits. It accelerates our learning by matching us to optimal strategies and improves our decisions with evidence-based insights.
And it frees up our time.
It frees up human time from routine monitoring and complex analysis, and it gives that time back to us for creative work, for applying our values, for human connection. The AI provides the what is happening. The human provides the what should we do and the why it matters.
Let's look at some of the new ideas and innovations this framework could enable. Starting at the personal level, the Universal Life Optimizer. This sounds like the ultimate personal assistant.
It's essentially a hyper-integrated personal assistant that monitors all aspects of your life, biological, psychological, scheduling, and provides unified recommendations. It doesn't just manage your calendar, it manages your energy levels, your attention span, your social needs.
Give us a concrete example of how that would work. That seamless coordination between personal and public data.
Okay, imagine your personal system, your ULO, detects from your sleep patterns and heart rate that you're entering a period of high cognitive fatigue.
So I'm tired and not thinking clearly.
Right. At the same time, the public system detects a major upcoming traffic disruption on your typical route to work and a surge in local air pollution. The ULO integrates all of that, your health, the environment, logistics, and it might recommend not just a different route, but also suggest delaying your complex tasks until the afternoon, or maybe even recommend working from home.
So it optimizes my energy and health while also reducing urban congestion.
All at once.
Scaling up from that, we have predictive governance systems. This sounds like running virtual governments to test policies.
That's exactly what it is. These systems act as future scenario simulators. They test policies in these high-fidelity virtual environments before they're implemented in the real world. They can model complex feedback loops and system interactions over decades to identify those unintended consequences early.
So no more solving one problem only to create 3 new ones downstream.
That's the goal. A climate policy simulator, for example, could show the economic, social, and environmental impacts of a carbon tax over 30 years, detailing localized impacts on employment, housing costs, and geopolitical stability. It moves policy from political calculation to demonstrable results.
Then there's adaptive infrastructure, self-optimizing cities. This goes back to those massive efficiency gains we discussed.
Adaptive infrastructure is physical infrastructure that learns usage patterns in real time. Energy grids that predict and adapt to demand, supply chains that automatically reroute, buildings that adjust their environment based on the people inside.
And the source gives that powerful example of smart traffic lights.
Right, smart traffic lights that learn commuter patterns, predict traffic flow minutes in advance, and reduce congestion in city centers by a verifiable 30%. That's physical efficiency driven by data.
And linking all this together are collaborative AI human teams. The system can't just spit out a recommendation. The human needs to understand why.
This is where that augmentation philosophy is paramount. The AI provides the sophisticated pattern-based insights, but we, the humans, apply the necessary ethical constraints, our values, our creativity, our intuition.
So it's a dialogue.
It has to be. And that demands that the AI provide a transparent explanation of its reasoning, what we call explainable AI, or XAI. In a medical setting, the AI might identify a high-risk pattern, the what, but the doctor applies their clinical judgment, considering the patient's personal context and values, to decide the why and how to proceed.
So let's look at the deployment scale. Where exactly is this system intended to operate?
It's designed for universal deployment across every major societal function. In the healthcare system, it's for real-time patient monitoring and diagnostic support. In the education system, it's for enabling those adaptive learning environments.
In the economic system.
Driving market prediction, high-accuracy fraud detection, and targeting interventions for poverty reduction. In the governance system, it's for evidence-based policymaking, optimizing public services, and urban planning.
And for the planet and society.
In the environmental system, it's for optimizing climate action and conservation. And in the social system, it's for fostering community development, reducing bias in the justice system, and providing early warnings for conflict resolution.
The scope is total. If it generates a pattern, biological, political, or physical AGIHR AI, is designed to monitor it and provide actionable guidance.
And if we connect that immense scale to the bigger picture, the sheer power and the pervasive nature of this system demand rigorous accountability. A system this powerful has to be utterly reliable.
Which means it has to be built on a robust framework for trust.
It's the only way it works.
So let's start with that reliability and trustworthiness framework. What are the current real-world limitations that have to be solved before a system this central to global life can be truly trusted?
The limitations really fall into three main categories. First is data quality. Bias in training data is a perpetual risk. You have to ensure the AI doesn't just perpetuate or amplify historical discrimination.
Garbage in, garbage out.
At a global scale. Second, there are algorithmic issues. The black box problem, where models lack interpretability, means we can't trust recommendations we don't understand, and computational costs can still limit true real-time processing.
And the third category?
Societal friction. Privacy concerns currently limit the data availability that's essential for this kind of comprehensive pattern recognition.
So how does the framework propose building trust and overcoming those limitations?
It mandates a highly structured, multi-layered approach. It comes down to three things: transparency, validation, and safety.
Okay, transparency or explainable AI, XAI. That seems crucial for user adoption. If the AI recommends a city redesign, the mayor needs to know why.
XAI is non-negotiable for any critical system. The AI has to show its reasoning, provide confidence scores for its predictions, and undergo mandatory algorithm audits to reveal potential biases and confirm where the data came from.
And validation, that's about making sure it's accurate.
It's about rigorous testing, using multiple different models to cross-check results. If 3 different models all predict the same recession warning, your confidence is much higher. And you have to have human oversight for all critical, irreversible decisions.
And the safety mechanisms for a global-scale system must be absolute.
They have to be. This includes fail-safe defaults that trigger if the system gets confused, maintaining a human in the loop for all high-stakes decisions, rigorous testing in those simulated environments, and a mandatory gradual deployment. You don't just flip a switch on a system like this.
Now, it's important to note that confidence is already very high in some specific domains, even with today's narrower systems.
It is. And these achievements set a baseline expectation. The sources cite current medical diagnosis accuracy at 85% to 95%, which is comparable to, or even better than, human specialists in some fields.
And financial fraud detection.
Achieving 90% to 95% accuracy. That's a huge improvement cited as 4 to 10 times better than relying only on manual methods. So we know the predictive power is achievable.
Let's talk timeline. This sounds like a decades-long effort, but the roadmap provided is surprisingly specific. It lays out a defined path.
It does. It begins with our current status in 2025. Narrow AI excels. The hardware is getting close to brain scale capacity in some labs, but that critical integration across the 7 domains and the energy efficiency targets, those are still the primary bottlenecks.
The near-term development from 2025 to 2030 is broken into 2 intensive phases.
Phase 1, foundation building, from 2025 to 2027, is all about solving that energy paradox. The key milestone is getting neuromorphic chips to achieve 10x energy efficiency. This phase also includes deploying the distributed computing networks and, crucially, establishing those ethical governance frameworks.
And Phase 2, integration and scaling from 2027 to 2030.
That's all about connecting the silos, creating unified platforms that let data flow between the domains while ensuring strict privacy. The deployment targets here are ambitious sociological markers. 50% of hospitals using AI diagnostic support and adaptive learning systems in 30% of schools globally.
Then comes the really critical period for AGI emergence, the medium term.
Phase 3, from 2030 to 2040, is the decade where AGI is expected to emerge. Based on expert surveys cited in the sources, there's a 50% probability of achieving AGI by 2040, with a significant 25% to 40% probability by 2030.
And the hardware milestones.
Brain-scale neuromorphic systems become commercially available, and energy efficiency consistently hits that human brain level, around 20 watts per unit.
And the long-term vision, Phase 4, brings full system maturity.
Phase 4, from 2040 to 2060, involves complete societal integration and superhuman capabilities. The system will be capable of superhuman pattern recognition, decades ahead forecasting, and autonomous management of routine societal functions like power grids and traffic.
Finally, we reach the most profound, maybe the most philosophical question raised by the sources: the paradox of humanity. Why build this ultimate pattern recognition system if the recurring pattern of humanity throughout all of history is to create magnificent things, cities, knowledge, ecosystems, and then repeatedly destroy them through war, burning libraries, and environmental degradation?
This addresses a fundamental fatalistic trap, and the source acknowledges that this destructive pattern is real and it is persistent. AGI-HR AI is built precisely to not succumb to that pattern, but to identify it and to interrupt it. It's designed to provide humanity with a clear mirror reflecting its own historical failures so it can finally break that destructive cycle.
How does it interrupt it? Is the AI making some kind of moral judgment?
No, it's not a moral judge. It interrupts the cycle through pure pattern analysis. It analyzes every historical failure pattern, from the collapse of empires to localized policy failures, and it identifies the exact early warning signs of those destructive trajectories.
And then what?
Crucially, it then provides alternative pathways that it has learned from historical successes and near misses. It continuously updates its understanding of our cognitive biases and our collective behavioral weaknesses to help us steer away from them.
So the core purpose of building this isn't about creating a perfect technological intelligence, but about accelerating our own collective wisdom, giving us the evidence we need to finally choose a better path.
Exactly. The focus is on amplifying our constructive aspects, enhancing our collective wisdom, letting us learn from mistakes much faster, giving us perfect visibility of consequences before they happen, and building tangible mechanisms for global cooperation based on demonstrable mutual benefit. It's designed to accelerate our own behavioral evolution.
This has been a truly monumental exploration, a framework designed to look at the world at every single scale, from a 20-watt efficiency goal all the way up to preventing global self-destruction.
The sheer scale of it is just breathtaking. From needing 68 terabytes of memory for brain-scale emulation to its moral goal of preventing the destructive cycles that have plagued human history. It presents us with an unprecedented opportunity for collective foresight.
And as we've seen, the system clearly defines 6 domains where humans remain absolutely essential. It's a powerful counterpoint to the AI's pattern recognition. The AI can find the optimal path, but we have to define the destination.
We do.
Humans are responsible for. Values deciding what we should optimize for, efficiency or equity. Wisdom contextualizing the insights with lived experience. Creativity imagining possibilities beyond the existing patterns. Meaning, love, and spirit.
The final reflection is clear. AGI-HR AI is not about replacing humanity, but about amplifying our best qualities while mitigating our worst. The pattern of our history is undeniable. We must either learn to recognize and interrupt our destructive patterns, or they will eventually overwhelm us. This framework offers humanity a chance to finally see ourselves clearly enough to choose a more resilient, constructive future.
So this leaves us with a final provocative thought for you, the listener, to consider as we move into that crucial early phase of this framework, phase 1, the first 1 to 3 years. The technical requirements, like those neuromorphic chips, are daunting, but they're being aggressively worked on. The human requirements, though, are arguably much tougher. What systems, beyond the technical, do you believe need to be put in place right now to ensure AGIH AI is built wisely, with transparency, with humility, and in genuine service to humanity? Specifically, look at those phase 1 checklist items we mentioned. Establishing comprehensive ethical governance frameworks, building privacy-preserving data infrastructure that actually works, and implementing public education programs to demystify all this. Which of those human-centric foundations is the most critical to secure in these first few years to ensure the promise of AGIHR AI outweighs the paradox of human nature?
Thank you for joining us.
Yeah.
We'll see you soon.
This is DigitView.